Welcome back after Thanksgiving. I hope you all had a great break. And thanks for coming to the guest lecture today. It's my great pleasure to introduce Mona Vernon. She's the Vice President at the Data Innovation Lab at Thomson Reuters here in Boston, which is a very young lab, a year and a half old. And she's going to tell us all about what they're doing in data science. And she brought along Dr. Brian Olisny, the Director of Data Science, who apparently was her first hire at the Data Lab, and the latest member of the Data Lab, Andrew Mulder, who's a data scientist, and today is Andrew's first day. So let's give all of them a big round of applause.
Thank you. It's a pleasure to be here today and meeting all of you. What I was hoping to do is start with some business context, and the reason is that we set up the Data Innovation Lab at Thomson Reuters really because we think it's a huge business opportunity for us to think about what these tools can do in many businesses, including ours. So I was going to share basically a first piece is a little bit about what is a data lab, what we do and how we do data science, giving you a little bit of context of what Thomson Reuters does and why that works with the lab. And then what I wanted to share with you is some frameworks around monetizing data and thinking about data business models, something I shared at the Digital Summit at HBS about a week ago. And I thought it would be good context to think about what are all the business opportunities around the tools that you guys are using and building, and then switch into some live demos and share with you some analytics and visualization projects we've done in the lab, and hope that along the way, between what Brian and I are going to share with you, you interrupt us with questions. So feel free to raise your hand, shoot out if I'm not looking in your direction, and ask any question through the process. So I'm Mona Vernon. I run the lab. I'm an engineer by training and have recently basically transitioned into more of a business role after a stint at MIT to get a degree in engineering systems and management. And about 2 years ago, had the opportunity of reporting to the Chief Technology Officer to spun off an enterprise-wide data science practice, starting with a lab here in Boston. So I'll tell you a little bit about that. And with me, as mentioned, I have data scientists that can really answer some of your questions in practicing data science. So a little bit about Thomson Reuters. We have a lot of data, and we're essentially in the business of delivering that data to what we call knowledge workers or professionals. And we serve all these different segments. So we offer news and financial data through various formats, whether it's large data feeds or applications to financial institutions. We also have a growing business in managing various types of risks of being in business. And we'll talk a little bit about that in the demos, all the way from regulatory risk, business risk, supply chain risk, financial risk. We have a large business which includes several products like Westlaw. So those products are really there to help lawyers make better decisions and be better at doing their work. And we have the same sort of suite of products in our tax and accounting business, as well as helping the life cycle of innovation in IP and science. And of course, the Reuters part of Thomson Reuters is the large and trusted army of journalists that span around the globe and bring critical news that feeds across many of our products, but is part of our news organization. So here's an example to help you think about, well, what is the breadth of the data? So here's a German company. It's a pharmaceutical company. And so for that single company, if we looked at how many type of documents would have a mention of this company, you would find that it's available across all our business in this number of mentions. So we have that company mentioned in research, financial research, in the news, but we also see their mention in legal cases, and as well as in analysis of their sort of tax and accounting footprint, and of course in their patent portfolio, in the type of academic publication, and because it's a pharmaceutical company, it has a big presence in the drug discovery products we deliver. So it gives you a sense of really, for us, the variety of formats of data spanning from unstructured text to fast-moving news feed to structured financial data, really is an opportunity to start doing interesting analytics, and it also spans different languages. And here's another piece. I just lifted that from a post that David Craig, the head of our financial and risk business, wrote, and it's sort of giving you a sense a little bit about, well, you know, so for us, what do we mean by big data? Obviously, there is many definitions of it and various scale, but just in our financial and risk business, we move a lot of data. For instance, the real-time pricing is by itself 10 billion bytes of data on an average day, and that volume is increasing like everywhere else. So we're getting, you know, a lot more data in a day than we did in a month 5 years ago. We're also starting to use the tools that you are learning and starting to apply, like predictive analytics, so that we can better model, curate the data so that it's easier to be basically consumed by our customers using predictive analytics for the tagging, extracting and tagging of entities. We are doing semantic analytics that's used and deployed, for instance, for sentiment analysis of the news. So how, you know, what does this piece of news mean? And that's important if you're trading on the news. And then, as I mentioned, we do this risk business. So we do a lot of monitoring of website to figure out whether there is risks of fraud. And because we run a fixed income, a foreign exchange platform, we actually are using machine learning to look at suspicious trading patterns and detect fraud. And that's just in our financial and risk business. So these data science tools are now becoming part of the way we do business. They are part of the expectation of customers in our space, and frankly, I would think in every segment of the industries, any industries you might look, you'll start seeing people look for data scientists, look to leverage data to make better decisions, and that's the really great opportunity around these data science tools. So I'm going to pivot now to talk about the lab. I think that is a model you'll see in a lot of teams that you might join, whether it's in a small company or basically a large company. So what does a data science team do, or what is sort of the way we're organized? So in our case, we started about 1.5 years ago, and really our idea was to work very closely with customer, having this sort of rapid iteration with our customers to figure out what can be built on top of a lot of data from various formats, as I mentioned, from text to numeric, to come up with new analytics. And we're looking at a lot of data set, not only inside the company, but as well from open data and external partners. So some of the projects, and we'll give you some examples with the live demos, include essentially proof of concepts and interactive visualization to kind of get a sense of whether that's the right type of solution to do data-driven decision making. And the way we do this is we have a lot of domain-specific content that requires a lot of expertise in just really understanding the data set. And I think that's what happened when you look at a lot of variety in the data, is you need to bring content experts into the team that's doing the data science work. So we do that with our what we call content expert or domain expert. So let's say we're looking at legal litigation and the legal corpus, then we need to bring experts in that field to better understand and work with our data scientists. In some cases, we actually have that expertise in the same person. So we have a lawyer from Harvard Law School that happens to be really excited about deep learning and kind of brings the two pieces together. And then we work with customers and vendors specifically around new technologies we might apply, like open source analytics tool. So this is our process. I think that slide is available in many places. In our case, the piece that I think is sort of worth noting is this curation piece. So that's the business that Thomson Reuters has been in for a really long time. It's increasingly done more with more automation, and that's actually a place where tools like machine learning come in handy. But we have a long history of creating this trusted, highly precise data sets, which help us actually quickly build more precise analytics. But there is a whole piece of work around curation, and that includes creating some semi-structure on top of the unstructured text, where we create our own taxonomies, for instance, in our legal documents, or being able to resolve entities so that you can connect different data sets around a company, like the example I gave of that pharmaceutical company. So, and we can talk more about that step as we go to the demos. So, our process really started about starting with understanding what is it that we want to build? Like, what is the question of a customer or a business opportunity that we want to go after? And that actually drives looking for the data and acquiring the data. That could be either sitting in a big data lake that we have inside the company. It might be acquiring that data from the outside. It might be getting it from a partner. And then that data probably comes in a form that requires a lot of hard work. That's the step that people call data wrangling, but it's actually figuring out what the format is, what the data means, and then getting it to that curation. And then we basically get through understanding how we would model it, analyze it, and build this what we call minimum viable product, which is a working prototype with visualization and analytics that we can iterate with customers. So some of the sample projects, and we'll show you some, we're exceedingly getting excited about knowledge graphs and actually doing some graph-based analytics. There is a lot of value in doing that kind of work, but we're doing some machine learning, predictive analytics. We're doing a lot of data mining around new data sources and looking at what they could mean in combination of, for instance, building better financial models. What happens if you start pulling in a lot of new data that comes from IoT or comes from your mobile phone and so on, and thinking carefully about how to do that in a trusted manner. So we'll give you some of those examples, and we work very closely with the startup ecosystem as well as working closely with academics. So I just came from a conference at MIT. We have partnerships with the big universities that gives us access to sort of the latest future thinking about some of these tools and how they're evolving. So I think I talked about that, but that's sort of the way we think about what we do. And that's another slide that's a way to think about, well, what's a data scientist? What do you mean by that? And in our world, we think very carefully about having a blend of business skills and ideally with the domain that we're selling into. So if you're selling to, the big banks, it'd be great to have a financial background so you understand that space, you understand the data, you understand the way people consume that information. Or if you're selling to lawyers and you're helping lawyers better predict, for instance, what would happen in a litigation, then understanding the legal domain makes sense. So there's that sort of business context that's helpful. And then in our world, we care very deeply about how comfortable you are to integrate data together. I think that's really important. Yes? The y-axis is an estimate from each individual on a scale of 0 to 100, how they're thinking about their skills. So if you do 0 to 100, what's the skill set you bring to the table? It's not a very scientific method, but it's your own estimate of what's your blend of skills. Typically, we put this on for non-technical people, like business folks, to try to explain what data science is for them. So the next section I wanted to talk about is, so why is there how is data science turning into business opportunity? And this might be, it's really, in my view, the beginning of a big shift into a flurry of new business models that really are starting to emerge. Some of them are already well established, and they really are all, at the core of them, enabled by a whole set of new technologies and analytics that enable them. So I wanted to share this framework with you guys, and my thinking is that whatever jobs you get out there, you'll be playing in one or more of those verticals that I'll be presenting here, and I'd love to get your thought about where you see some other opportunities or maybe some that you've already seen. So before I do that, this is our own definition of the various data that's a type that's available out there. It might be a little specific to our world, but I figured for better or worse, they're worth sharing with you. I think it's pretty specific to some sense to the sort of fintech world, and this whole space of fintech startup is kind of booming, but some of it is valid across other sectors. So one is raw data. So that's data that you might get from scraping the web, that you might be collecting from IoT, that you might be getting from a lot of text, unstructured text, and essentially before you do anything to it. Time series is specific into the financial world often, but it's really the notion that there is a data moving through time, so like economic indicators across time. So we call those time series. And in our space, there is a really important set of reference data that we rely on to make sure that we can build analytics that are tapped into trusted information about companies and their financial, and we call those reference data in the financial space. Analytics is obvious, same with predictive analytics for you guys here. And then we kind of took away from the raw data this notion of data exhaust. And so that's sort of at the heart of a lot of conversations around data privacy, for instance. And it's this idea that if you're holding a mobile phone or you're surfing the web, you might be leaving a trace behind. Or, for instance, there might be a whole set of activities in a factory or in a car for which you're collecting data. And the primary purpose of some of the data collection might be, for instance, in a tractor to make sure that you do to analyze the data from the tractor or the jet engine for servicing. But that data might be useful on the aggregate to a different type of customer or a different type of user to get a completely different insight. So an example might be that I might be collecting all this IoT data from a whole set of tractors on the field in the US, and that's very helpful to help service them. But on the aggregate, they might give me a sense of real-time crop yield for the US, and that might be consumed by a different kind of customer. So this notion of data exhaust versus raw data is really there to sort of highlight that you should be thinking about what data you're collecting, and that might be a whole set of different purpose beyond what you've been thinking about that could actually lead to some business opportunity. And that there's some really careful thinking about the terms and the policies in doing that. And then the last bit is linked to what I talked about earlier, sort of this notion that companies like Facebook or LinkedIn or Google are increasingly investing in knowledge graphs. And in our case, we think carefully about entity analytics because there's some really interesting insights we can get for our customer in that space. And I don't know if that's something you guys looked at in terms of graph-based, but that's kind of, in our world, an emerging area of data science, if we can bundle it under that term. So lots of data, we talked about that. There is a lot of it out there. It's increasingly growing. And the idea that really data science enables building analytics, and it's a big growing marketplace. So this idea of analytics as a service or better delivering analytics makes is predicted to be a big business opportunity. So the big takeaway is no matter what business you're in, you are going to start thinking about your data as this raw material that can be used to create revenue, one way or another. That's the new gold. And my attempt here is to help you with a framework to think about what are the various opportunities or the way you could think about where data can be turned into revenue. So we created sort of 3 buckets. And those 3 buckets are sort of using the data to run your business better, right? So I have a complicated supply chain because I'm Walmart. And if I'm better at doing analytics on my data, then I can be better at optimizing my supply chain, and it ultimately turns into creating more value for customers, and it's basically the right thing to do. So, and you know, a lot of companies are doing that very well. A lot are doing increasingly more of that, and it's sort of the big, you know, opportunity to use more of this sort of cloud-based tools like Salesforce and others. We sort of separate this whole new set of internal analytics, and I think a lot of new data science jobs out there are in that category of internal analytics. So those are, you know, until now, my Salesforce goes and, you know, may not necessarily be using a lot of predictive analytics or analytical model, but they could be walking around with an iPad and Tableau and sort of look at data as they're thinking about how to create more sales or retain customers. And or, you know, my HR might be starting to use data analytics to make better hiring decision or talent management. So there's sort of new areas of running a business that can benefit from data science and analytics, and there is not only a whole set of new startups and new companies getting into that space, but increasingly there are customers for it and wanting to apply this data-driven decision-making to other areas than running their IT operations. And then the last piece is, how do you start selling analytics or data-driven business model? And that's sort of this idea that you can sell data or data products to a new market that you were perhaps not initially in. So those are the three models in a different view. And sort of this way we look at it is, in some cases, you can just sell the raw data. You know, you have it, you collected it, you happen to be collecting this data that could be really useful, and I'll give you some example of that, and that's a business on its own. Another is selling analytics, and that's where you need data scientists because you need to build those analytics. And there's examples we'll share with you, but a lot of startups are starting to offer some really interesting products around that space, as well as other companies. And then the third is the one that you might be using when you take an Uber to come to class, or you know, stay at an Airbnb on vacation. It's this idea that data is the way you build a platform, and that creating businesses like data platform businesses actually means that you have very sophisticated analytics to create the marketplace from looking at basically the usage data on both sides, or basically compiling a marketplace through data. And so here's a couple of examples. I'll go through this so that we can get through some of the demos and sort of get closer to the data science piece. But you know, the raw data, the examples are Target has point of sale data because obviously they sell lots of things, but that data is really useful to help their supplier better predict what to deliver. Nielsen has a lot of data around customer shopper behavior, and that can be sold as is and so on. And then there's real traffic data that is sold to people that make GPS. And so that's just the raw data business. The data analytics, I have a few examples, and some of them are sort of futuristic, but they're happening. So ARPA-E, which is the environmental ARPA arm, is starting to look at basically funding connecting genomic data to build algorithms to connect those gene data with performance of a plant. And there is, you know, examples of a Boston-based startup that pulled shipping level, container level shipping data to start figuring out how that basically gives you a sense of financial the commodities market. And that's actually an example that's really interesting because that data was so valuable, it didn't actually make sense to sell it, nor did it make sense to sell the analytics. It actually became best used to have one single customer, and it became its own hedge fund. So this notion of thinking really hard about or partnering with someone who can really help you think about the economics of how do you sell your analytics, how many people do you sell it to, how do you tier the pricing. That's actually a really good space to befriend an economist if there are some in the room, that's a good place to combine your data science skill and your economic skills. And then the last one we really talked about, so we have a Thomson Reuters App Studio where we basically provide our data for people to build app, and the idea is that the apps are built and they can be matched with the right customers, and we create a marketplace. Salesforce has it, and again, those are sort of the Airbnb and Uber and type of data platforms, and for those you need a lot of sophisticated analytics. So that sounds all great. So everybody's going to make lots of money and build lots of unicorn startups and piece of cake, right? Well, it is actually a lot of hard work to get there. So those are the things we sort of think about in the financial space. So how do we think about getting the historical data, making sure you have the right to the data. So if you think about data exhaust, you may have collected a whole set of data about your users for a specific purpose, but you may have not thought about how to change those terms and apply the data for a different reason. I mean, just yesterday, TD Bank was in the news with a big Twitter uproar about the way they're thinking about using credit card data for different purposes. So those actually are a big deal, and those require becoming friends with lawyers to make sure they can help you think about the terms of the data used for you to build cool analytics on top of them. And so this whole notion of the sort of rights to the data and rights to the analytics. So those are the main thing, and then we'll show you the example, but I think in our space, when we start looking at all this interesting new data set, we have to be able to connect it accurately to an entity, like a company name, and make sure that that's done very accurately, and that becomes actually critical. So I'll stop here. If there's no question on this whole data monetization space, we can sort of pivot to live demos and showing you guys what we've built in the lab. All right.
I have a question.
Yeah.
Do you think there's a difference between looking at this from a corporate perspective, from a large company point of view, versus looking at a startup point of view?
So that's a good question. I think the thing to keep in mind, so I come from the startup world. The startups need to sell to big companies, and so the startups that are building analytic solutions and interesting technologies. So, I mean, I'll give you an example of one that I think is fascinating. IASD is a startup spin off from Stanford. They do topological machine learning, and what they had to figure out is, okay, the technology is really cool, right? What is it useful for? And they eventually figured out that actually it was really powerful to predict credit card default risk by working with a customer. When I met them, they were thinking they could do all kind of things around genomics or whatever. So the importance of finding out, so in my view, big companies are trying to figure out how to use these tools. It's an opportunity for a startup to come in and help them with a solution. And so the more you understand some of the less obvious markets, then the more opportunity you get. There's a quote from a guy from Silicon Valley Bank, which is, the hype is in B2C, but the money is in B2B. And that's because it's hard to learn about some of these other markets, but there's a ton of opportunity and a ton of really interesting data if you think about IoT. So I think they're different. They both meet at the marketplace level. And in my mind, it doesn't really matter who comes up with those solutions, but they're going to be increasingly rising.
Anything else?
No, I think you were having the regular.
Oh, why is this not projecting?
Yeah, it's always doing that.
I think you might have a mirror.
Oh. Okay, here we go. Okay, Sorry about that. So, so I'm just going to go through a few of the projects that we've been working on and talk about sort of our approach and why we did what we did and how we did it and so on. So in general, one of the purposes of the lab was to leverage the big data technology stack and the big data infrastructure to take all of Thomson Reuters' various data sets, which we'd acquired over the years. And so Thomson Reuters has grown over the years to a large extent by acquisition. So we acquired various data providers, and so that meant that people had businesses where they were selling data, and basically they attended to their own data set. They sort of curated their own data and they sold it, and that was a very profitable business, but the data was to a certain extent siloed. Thomson Reuters had the good sense about 5 or so years ago when they merged with Reuters, Thomson and Reuters merged, to start thinking about a data model for the entire company, which at least in principle made the data joinable. So there was an effort to think about what are the core entities that we're modeling, what attributes do those entities have, develop a data model that was centralized, but it really didn't allow you to actually join this data according to that data model. But now that we have this big data where we can ingest all of these data sets into a giant data lake, we can actually join the data in practice as well as in theory based on this data model. So one of the first projects that we did in the lab was so our charter was to think about how could we combine data models that data sets that hadn't really been joined together to do something innovative for our customers. So we took legal data. So the legal part of the business is the second largest part of the business, and data from our IP and science, our intellectual property data about patents, and combine them into a product that could, or a project at least, that could be traded on, that financial analysts would be interested in, and so on. So the idea was, let's take all of the data that we have about when patents have been litigated, and let's use that to train a model based on features of the patents to predict in the future which patents are most likely to be litigated, brought to court. And obviously, if you can predict which patents are going to be litigated, then that informs a lot of decision making about companies that you might want to buy in a merger and acquisition scenario. It might, diversifying your portfolio, all sorts of things. So that's what we did here, and that's what this interface does. So this was using standard machine learning tools, using Hive and Spark to aggregate all this data from the patent side of the world, and training a model of when the patents would be litigated by looking at not only the features of the patent, that is, who owned the patent when it was assigned, and how many claims the patent has, things like that. What's the technological area that the patent was in. But it also turns out that it's very important to look at what happens to a patent after it's granted. So things about, does the patent change hands? When it changes hands, does it change hands from a big company to a small company, or from a small company to a big company? All of those sorts of features were aggregated and used to train the machine learning model, and then predict the litigation of patents. So let me just show here, so US 578-1752. Oh, I'm sorry, this is wrong interface. Here we go. So this is a patent that's been in the news recently. So this is that wasn't so good. what happened here? All right, well, let's look at here. All right, so we've offended the demo gods here. Well, I don't know why this isn't working. Yeah, this is live. Well, so anyway, we can see this one example, for example. So here's a patent, and it's basically predicted that there's a 46.4% likelihood that this patent's going to be litigated within the lifetime of the patent. And so this took a lot of aggregating of the data, cleaning up the data, and one of the main things that was a technological or curatorial hang up here was identifying who actually owns the patent at the time and mapping that to some kind of identifier that we could aggregate things to. So one of the things that, for example, patent trolls, people who litigate, whose business model is basically litigating patents, one of the things that they do is they like to obscure their ownership of patents. So they will sort of obfuscate their name in patent assignee data. So figuring out exactly who owned patents and rolling them up to a single user took some doing. So that was the patent litigation project. So I'll stop there with that. Yep.
What algorithm did you use to generate this predicted probability? So what fund did you use when you aggregated all this data? And the second question is, what's your confidence interval, or what's kind of your uncertainty? Because that's a pretty precise number with 4 digits of precision. How is it, like plus or minus 5%, plus or minus 20%?
Yeah, that's a great question. So the model that was used to train this, so this was actually not something that I worked on in particular, but they've gone back and forth and used lots of different machine learning packages, this kind of standard things in scikit-learn and so on, different models to train the data, to train the model. And I'm not sure exactly what the current algorithm is that they're using. I believe that they got up to something like 80% area under the curve for the overall accuracy of the model. In general, this is a very, very unbalanced data set that only about 1% of all patents get litigated ever. So you can achieve 99% accuracy just by saying that no patents, that just by saying it, nothing will ever get litigated. So, but the area under the curve model says that gives you an 80% figure currently. But the confidence interval with the probability, I have to say I'm not sure what that would be right now. But I can get back to you if you want to send me an email. Anything else? Okay, so another thing then I'd want to show is how do I get back to this? So this is one of the other projects that we did was and I'll show this too, was a project on geopolitical risk a dashboard to understand the geopolitical risk of a portfolio of stocks. And so one of the things that we were thinking about when we were doing this project and aggregating a lot of data to understand the geopolitical situation of a country was data about food security and food insecurity and the relationship of food security to civil unrest. And so word got out about this, and the company actually has a really interesting report that it was working on. Oh, actually, this is it, that I would recommend everyone looking at, called this 9 Billion Bowls report. So the idea here is that currently, with our current population of 6 billion people or so in the world, we're using 80% of the arable land in the world in order to feed that population. But the population is going to increase worldwide to 9 billion in 2050. And so how are we going to increase our global food capacity in order to feed all these people? So this whole idea about the food insecurity and civil unrest seemed like a good way to frame or to tee up that report. So what the report contains is lots of data, lots of interviews with people within Thomson Reuters who are working on food-related issues and data that supports data-driven decisions about improving our capacity to feed the world. And so they asked us to do a visualization of the data to illustrate the food security part. And so that's what we have here. So this is in this visualization with our visualization guy, Brian Romer, these circles represent various food riots. And there's, when you hover over one, it indicates where in the world that took place. And then we have a timeline of these events. The size of the circles represents the severity of the food riot. And then underneath this graph, we have these graphs of different commodity metrics. So this gray line is the price of oil, and this blue line is the aggregated UN food price index. So you can see, for example, in this a period of time from around 2007, 2008, there's a large number of food-related riots in the world, and we can see that the price of oil is spiking at that time, which is driving up the price of food, which then is leading to all of these food-related unrest. And then we tied this data then to measures of political stability and instability, and the color of these dots then represents whether the country was becoming more or less stable after these civil unrest events. So this is an example of something that we really didn't set out to do, but was more or less data exhaust, as Mona said, from another project that our external communications people thought was really useful in framing the story of the relationship of food insecurity to civil unrest. And that's really an important skill also as a data scientist, is this ability to tell stories with data, be able to come up with visualizations that make sense to end users who are not necessarily as technical, and allow them to then grasp what's going on with the data sets. So any questions about this? Okay, so let me get rid of this, and we'll try showing the other. So this is fascinating here, watching me navigate my file system. Let's see, here we are. So as you can see, what we're using, we do a lot of work in building Shiny apps in order to just basically provide a nice front end for data, and just being able to have a nice interface that you can show to customers and navigate the data and make things much more concrete is very important then for people getting a sense of what you're doing and what you can do. So obviously we don't really try to make, to put too much effort into making the UIs look professional, and these aren't the sorts of UIs that you would ship within Icon or so on. But they're at least, sort of presentable enough that you can take them to the customer, show them the kinds of analytics you're doing, and get feedback, which is an important part of this iterative lean process that Mona talked about. So in this geopolitical risk dashboard, there are essentially two components. So on the one hand, what we want to do is, well, the purpose of the project was to say, Thomson Reuters has lots of data that allows people to navigate, or that quantifies various aspects of the geopolitical situation around the world. And but there wasn't really a way for anyone to basically aggregate all that data into any kind of unified metric in order to say, for example, you are an asset manager at an asset management company, and you want to understand the geopolitical risk associated with your portfolio of stocks. That is, which countries is my portfolio of stocks exposed to, and how politically risky is the situation in those countries? So those are the two parts of this this data. So let me just add some companies to my portfolio. I'm going to add a bunch of oil companies. Okay, and so this blue map then shows my exposure across the world to the various countries then that based on this portfolio. So what we've done here is our colleagues at StarMine, which is a quantitative startup that Thomson Reuters acquired in San Francisco, they mine stock filings, SEC filings, and look at the distribution of the countries primarily where the various companies report revenues. So where do they make their money? They automatically mine these things from their filings and add some other information about the currencies that the stock trades in and the exchanges that a company trades on, and use that to represent in a fractional way what proportion of the company's business is done in this country, what proportion is done in this other country, and so on, up to 10 countries. So that's the country exposure piece then. So I've aggregated for all of my countries here, the various countries that I'm exposed to. And then we have a and then we have a risk model for each country. So we've aggregated a lot of data about the riskiness of each country based on the geopolitical situation as it's updated. And then we distribute the risk over the the countries that you're exposed to and get this map of where your greatest exposure is. So for example, here in the country exposure, I'm most exposed to the US, but based on risk then, my highest risk exposure is to China, based on this portfolio of stocks. So this is what this involves then is aggregating lots and lots of different data sets, and I won't go over all of them, but we're aggregating sovereign risk models, we're aggregating the kinds of geopolitical risk metrics that you get from think tanks and NGOs, the UN and the World Bank and so on. We're aggregating data that we get just from looking at the volume of news and how it changes over time. So that's obviously an internal data set that we get from within TR, data that we get from mining press releases. So we have, Thomson Reuters has a product called Investor Briefs or SIGDEVs, and what that product does is it constantly mines company websites for releases of press releases, and it summarizes and sends alerts to subscribers within 15 minutes for the major exchanges and within the day for more obscure exchanges around the world. And it summarizes the event that's been expressed in that press release and codifies it according to a coding scheme and sends it out. So we aggregated some of this SIGDEV data to also understand the risk of various countries. Another interesting data set here is the GDELT data set and the Goldstein scores. Anyone familiar with GDELT or the Goldstein scores? So over the past 30 years or so, political scientists have developed these Goldstein metrics, and what they've done is they have a very codified way of associating event types with news headlines around the world. So this GDELT product is ingesting headlines from all over the world in various languages, automatically translating them when they aren't in English, assigning those headlines to specific event types, and then assigning a Goldstein metric to those headlines, where the Goldstein metric indicates to what extent is this type of event stabilizing or destabilizing for a country. And so then we aggregate those Goldstein scores over a period of time and put that as another dimension of the country risk. So basically, the idea here was that we wanted to take all of this data, make it accessible, make all of the metrics commensurable, roll it up into a single metric from my portfolio, and make that sort of navigable through this interface. So I'll just say that, so initially we did this, we aggregated about 20 data sets. We took it to see BlackRock, one of the largest asset management firms in the world. And they challenged us to come back and say, okay, we want to see you model some historical crises, like show us what your dashboard would have shown during the Ukraine crisis of 2014. So when we went back and tried to do that, we realized that a lot of the data that we had was too slow-moving and too reactive, really, to be useful for an asset manager to say, oh, there's something going wrong in Ukraine, I'm going to have to rebalance my portfolio. So we went back and added a lot of faster-moving data sets into this so that we could show that we could anticipate that things were going poorly in Ukraine, and that that was a signal that you would need to make some decisions about reallocating your portfolio, perhaps. So any questions about this? Yep.
Have there been any sort of predictions or actions taken by investors based on this kind of thing? Sometimes, you may have mistakes in the algorithm and stuff like that. So these mistakes follow through in the
Yeah, I mean, so part of the idea here is that we can correlate this then with movements in the market, or we could correlate it with a particular company's trading strategy and show whether if you had decided to trade based on this and you had done this, would that have turned out better or worse? So that kind of back testing is something that is very important to us and our customers. Anything else? Is there anything else I should show? I could show the world check stuff, or no?
So I think maybe what we could do is maybe stop here and ask if there's any question in terms of how we build those things, a technology stack, sort of questions about how you would, if you're Andrew and tomorrow you got to start building some of those things, what would be the questions you guys have, assuming that you're going to continue what you learn in this classroom into the real world? So go ahead.
So I think that the huge diversity of the type of data you have, I guess you can generate tons of hypotheses, assumptions, and if you have enough people, you probably can build all kinds of apps based on that. I guess my question is, how do you prioritize all those possibilities?
So that's a really good question, because that's actually the hardest part of it. And so the example so the first thing we do is we start figuring out where there is big business opportunities. And so our colleagues who look at the size of a market or something that could be really big, I think the ambition is that over time, the more we learn about the data, the more we can help them think about maybe markets they had not thought about. But at this early stage, we're sort of looking at this big space is really happening. So like an example for us is that it's increasingly important for companies, like right now, obviously sustainability is a big conversation with the Paris Summit, but it's also increasingly important for companies to be careful about how they do business, that they're not involved in money laundering, or they're not involved in human trafficking or slavery. And so that's something that's going to impact someone's business, and there is a role for us to play in that space. So that's the starting hypothesis. From there, there's a whole set of iteration to figure out what's the right data set, what's the most useful data set. So we have a process in vetting data, looking at its, so we do a lot of looking at the data and finding how useful it is, and figuring out what data should go into a model. And that's very iterative. But we can't really start with the data. That universe is too big, right?
And of world risk, both of those have very small signals for a lot of potential data coming in. So what techniques have you found that actually work in practice when there's so much information in such a small signal?
Well, I mean, I'd like to think that what we've done has worked. So with the with the geopolitical stuff, just making everything commensurable involved lots of sort of z-scoring things and aggregating them, and then being able to backtest against historical crises and things like that. So there wasn't really anything sort of super fancy going on mathematically beyond using that sort of aggregation. The litigation risk is using more or less standard machine learning techniques, and then of course the challenge always with machine learning is the feature engineering. What features really matter, and so those can be sort of endlessly tweaked. But at least in the patent space, there's sort of a finite set of possible features that you could use. Does that answer your question?
Well, thinking about these standard libraries that come with scikit-learn, for example, and none of those are particularly good at very low signals. So you can go through random forests or number of different techniques, and they don't really surface those things that are very rare events very well.
Right. So you definitely have to, when you're training, you have to sort of, rebalance your training sets so that you can pick up those low frequency events.
Any other question about tools or stacks or things that we use that could be valuable to you guys? I don't know, you guys all are in R or Python or what? Python, okay. Okay. Then I think that's...
I have a question. So what is the challenge in data integration across business units? I could imagine, and know from experience, that it's very challenging. It has to do with politics, it has to do with data formats, it ranges the gamut of technical and social challenges.
Yeah, so I think it's a combination, right? So I don't know how much you've covered in this class modeling, data modeling or information modeling and how critical that is, but it is very important to think about what information model you use, and then you have to get people to use that information model, and it might not, if you haven't used that one, you have to migrate to it, so that there should be some incentive to do that, so that's the human behavior. But then it's actually technically hard, right? So my colleague, Stephen Malinak, has this really good example of how difficult it is to find out who AT&T is. It might sound so obvious. Well, AT&T, it's a company, right? Well, it's actually really complicated. Which legal entity are you talking about? AT&T had multiple merger and acquisition over time, and so if I'm modeling in 92 versus 2010, what is that entity of AT&T is actually a really complicated question for which there isn't actually a really easy answer. And then on top of that, you have to think about its sort of parent organization. So if there is a lawsuit, did that happen at the subsidiary of AT&T and so on? And so one of the things we've done last year is we worked with Tim Berners-Lee's Open Data Institute, and we actually set up a Creative Commons around these permanent identifiers. And the reason we did that is that we figured as you start doing sophisticated models that involve entities, that's a problem everybody's going to have, and that it helps solve it. So we set that up here. There's still a lot more to be done, but right now it's really somewhat, it's definitely useful as we have it. And of course, we want to improve that to create a lot more elements like time view of it. But do you want to talk a little bit about that?
Yeah, actually, so this would actually be a good resource for the people in this class. So, one of the things that, so as I mentioned, our internal data model. So what we've done here is we've taken our internal data model and exposed the part of it that relates to companies, which is sort of our bread and butter, to the world at large. So there's an interface here that you can search for companies, which is of limited use. But you can also bulk download, and there's an API here that you can bulk match a huge number of companies, and there's 3.5 million companies for which we present data, and this data is presented in semantic web form, is Turtle, and in other formats. So you can, if you want then to, if you're doing a data project that involves aggregating information about companies, then one thing you can do is use these APIs to match mentions of companies and unstructured data to these perm IDs, use these perm IDs then to link data across various ways of referring to the company and so on. And then secondly, there's another service that is offered for free called OpenCalais. And what this does is it, I don't know, so let's see.
Go to Reuters.
Oh, hey, that's a good idea.
Something about Paris and beyond.
Okay. upsetting news. Maybe this is not the best thing to use here, but we'll take this text, and you can tag it. And what this, so Calais is a named entity recognition service, and it's also tied to the perm ID. So when it identifies a company that it has a perm ID for, it'll link that to the perm IDs here. So it also does some topic modeling and so on. So you can, yeah, so here's an organization. So NATO, NATO doesn't have a perm ID, it looks like. But you can, well, essentially what this service does as well is it creates an RDF representation of any document with the named entity markup embedded in it. So essentially you can run unstructured text through this service, create an RDF graph, repeat this as many times as you like. So you've got all of these RDF graphs, and then joining all of these RDF graphs creates a giant RDF graph that you can then do graph-based analytics and find paths between entities, which may or, none of which might be mentioned in the same document, and do those sort of graph-based analytics for the entities. So if you're going into data science, this is a very, very useful set of tools and resources to be able to do useful things at scale. So we, at 3.5 million companies, this is way by several times a larger set of company data than you get, for example, from Wikipedia or DBpedia.
Do you want to talk about the hackathon?
Oh, yeah.
Yeah, let's talk about that. So, I mean, the answer to your question is a combination, but I think when you get this sort of on the questions about knowledge representation and information models, I mean, those are really important to every company, startup, big company, and sort of having someone that thinks about that architecture is really important.
So as part of our, one of the current things that we're working on is using big data to understand the risk of slavery in the supply chain. So understanding to what extent various companies are exposed to forced labor within their own supply chain. And as part of that, we've become involved in some human trafficking, with some human trafficking NGOs locally. So in January, we're sponsoring a hackathon at District Hall, which is down in the Seaport, right near our office, which is a city-sponsored hackerspace. And the purpose of the hackathon is to work with this NGO to provide analytics to help reduce human trafficking in the US. And we'd be very excited for people from this class to join us for all or part of the weekend. There's going to be people from professionals, people from Thomson Reuters, people from Google, other places, as well as students from various colleges and universities around here. So please do join us if you have the time. Yeah. Oh, one question?
Is there a website that we can go to?
Yeah, so I just jumped the gun as far as the actual website isn't up yet. There will be an Eventbrite registration process. I'll send the information to our contact for this class, and hopefully she can forward it. Okay, great, thank you.